In this video, we will practice our basic integration techniques. The most useful tool of integration is the power rule of integration, which says if we have x raised to some power, if you want to take the integral, you add 1 to the exponent. So in this case, that's going to be a 3. And then you divide by the new exponent. So I'm going to show that by putting a 1/3 out in the front. Finally, you add the constant of integration. So this would be the answer. Looking at number 7, we need to rewrite this a little bit before we get started. You see the 1/4 right here. I'm going to take the x to the third power and move it out of the denominator. I'm going to write it as x to the -3 power. Now I'm ready to use the power rule of integration, which says that I can add 1 to this exponent. -3 plus 1 is -2. Then I need to divide by the new exponent. I'm going to show that as a -1/2. I'm actually going to move this negative sign over a little bit to leave room for the 1/4, which is still sitting here. I'm just going to bring that down. So I've got 1/4 times 1/2. Let's add the constant of integration. And the final answer will be -1/8 x to the -2 power plus c. So this is a perfectly acceptable answer for our integral. Another way you could write this would be -1/8 squared plus c. Number 8, I'm going to rewrite this a little bit as well. First of all, the square root of x is x to the 1/2 power, and the cube root is x to the 1/3 power. Next, I am going to distribute the 12x. So I'm going to have the integral of 12. When you multiply variables, you add the exponents. So I'm adding 1 plus 1/2. 1 is the same thing as 2/2. So in my mind, I'm thinking 2/2 plus 1/2. So that's going to give me x to the 3/2 power. And then 12x times x to the 1/3 power. So there's my 12. Now I'm doing 1 plus 1/3. 1 is the same thing as 3/3. So this will be 4/3. So x to the 4/3 power dx. Now I am all ready to use the power rule of integration. So I need to add 1 to this exponent. So adding 1 would be the same thing as adding 2/2. So this will be 5/2. So I have x to the 5/2 power. I will divide by the new exponent. When you divide by a fraction, you multiply by the reciprocal. So I'm going to end up with 2/5. Don't forget about the 12. That has always been there. So I'm going to put 12 times this. And now we move on to the next term. I think I'll write down the 12 first this time. So I'm going to have x to the, I need to add 1 to this power. So I'm adding 3/3. That's going to be 7/3. So I have x to the 7/3 power. Then I divide by the new exponent. Dividing by 7/3 is the same thing as multiplying by 3/7. Do not forget to include the constant of integration. So these 12s are going to multiply in the numerator. So I will end up with 24/5 times x to the 5/2 power plus 36/7 x to the 7/3 power plus c. So this is the answer. For number 9, I'm going to use the principle that I refer to as the a plus b over c rule, because I can always rewrite this as a over c plus b over c. So in this case, I can take my x to the 7th power and put that over 3x squared. There's my minus. And then I have 6x squared over 3x squared dx. Simplifying this a little bit, here's my 1/3. X to the 7th power divided by x squared is x to the 5th power. You subtract the exponents. And then minus. The x squared will cancel out, and then I just have 6 over 3, which is 2, dx. So I'm going to go term by term using my power rule of integration. So look at that x to the 5th power. Focus on it. I'm adding 1, so that'll be 6. I am dividing by my new exponent, so that's going to be 1/6. And don't forget about the 1/3 that has been there the whole time. Now moving on to this term, whoops, that should be a minus. So I know that when I take the integral of a constant, an x appears next to it. And then I will have the constant of integration. So really, this is going to be 1 over 18, x to the 6th power minus 2x plus c. So that's the final answer. Ooh, trig functions. Well, let's not get too scared. Let's distribute this secant and see what happens. So secant times secant will be secant squared. And then I will just write secant theta tangent theta. When you take the integral of something, you should be thinking the derivative of what? Maybe I'll write this down. The derivative of what will give you what you started with. That's what you should be thinking. So when you look at secant squared, all right, is there something you can take the derivative of that will give you secant squared as the answer? Sure there is. We know that the derivative of tangent is secant squared. So that's why if I take the integral right here, I'm going to end up with tangent. Okay, the derivative of tangent is secant squared, so this is the integral. What about secant tangent? Is there something that I can take the derivative of that would give me secant tangent as the answer? Sure there is. That is secant. The derivative of secant is secant tangent. So that makes secant the integral of secant tangent. And then you just add the constant of integration. So this is the answer. By the way, you can check your answer by taking the derivative. If you take the derivative, it should give you back what you started with. So, as I mentioned as I did the problem, the derivative of tangent is secant squared, and the derivative of secant is secant tangent. And this c is here because the derivative of a constant is 0, so it's going to go away anyway. So if we take the derivative of this answer, we get back what we started with. So you know it's right. For number 11, we need to use a tiny amount of our knowledge of identities, Pythagorean identities. The most famous identity was cosine squared theta plus, well, they're using x's. So let me say cosine squared x plus sine squared x is equal to 1. If you only know one identity, let it be this one. So if I wanted to get sine squared by itself, I would subtract cosine from both sides. And then that would give me 1 minus, well, let me say it this way. I'm trying to get sine squared by itself. So that would give me sine squared x is equal to 1 minus cosine squared x. So this is kind of another identity a little bit. So if I were to see 1 minus cosine squared someplace, I could replace it with sine squared x. Why am I mentioning this right now? Obviously because I have a 1 minus cosine squared right here. So let's make this substitution and put in sine squared x instead. 1 over sine squared, you say. Well, we know that the reciprocal of sine is cosecant. So this would be the same thing as the integral of cosecant squared. As you think about this integral, you should be asking yourself, the derivative of what will give me cosecant squared? Well, we definitely know that the derivative of tangent is secant squared, which reminds us that the derivative of cotangent is negative cosecant squared. That's really, really close to what we have here. So that means that the derivative of negative cotangent will equal cosecant squared. So that means negative cotangent must be the integral. Just slap a constant of integration on that and you have your answer. This does not look very friendly. Let's simplify by writing everything in terms of sine and cosine, and then we'll kind of see what happens. So tangent in the numerator there is sine x over cosine x. And then in the denominator, I think I'm going to change colors for some reason. In the denominator, I have sine x cosine x. When you divide a fraction by something, you know what, side lesson. If I have a over b, and then I wanted to divide that by c, the c just joins the denominator. So this would be the same thing as having a over b times c. So that's what I'm going to do here. I'm taking this fraction, this is like my a over b, and I'm dividing it by sine and I'm dividing it by cosine. So just like the c just came up and joined the denominator, the sine and the cosine are just going to come on up and join into the denominator. So this is going to give me the integral of, okay, so there's my sine x and here's my cosine x, all right? This is the original sine over cosine that you see. But the sine x that was here in red is going to join the denominator like this. The cosine is going to come up into the denominator as well. So I'm going to have cosine x like this. I forgot the dx. I'm just going to stick that on here. Two things will happen now. I notice that we have sine x over sine x. So these are going to cancel each other out. And then I also have cosine x times cosine x. That's cosine squared. So I now have the integral of 1 over cosine squared x dx. The reciprocal of cosine is secant. So this is the same thing as the integral of secant squared dx. As you do this integral, you should be asking yourself, the derivative of what is secant squared? And we know the derivative of tangent is secant squared. So that means tangent is the answer. Of course, we must include the constant of integration, but this is the answer.